I want to show you how to factor something that's called the difference of two squares. So we can see here that we have a polynomial, it's a binomial, it has two terms. And the first term is 16x squared, the second term is 1. And if you remember, 16 and 1, those are both perfect squares. And if we're not really sure where to go from here, we could always try to rewrite this like the standard form of a quadratic that we're used to. So 16x squared plus 0x minus 1. And if we chose to do this, we'd probably split the middle. So if I did 16 times negative 1, that'd be negative 16. And we need factors of negative 16 that add up to be 0, which would be 4 and negative 4. So I could rewrite this as 16x squared plus 4x minus 4x minus 1. And I'm taking you a long route through this. There's a much easier way to do this, but we're going to see what we find here in just a minute. So out of this first group, we could factor out 4x and have 4x plus 1. And out of the second group, we could factor out a negative 1 to get 4x plus 1. So this factors to be 4x plus 1 times 4x minus 1. I'm going to do the same thing over here to the second one. We have x squared minus 81. This is like 1x squared minus 81. And I'm going to go ahead and rewrite this 1x squared plus 0x minus 81. And if I look at this, I can multiply negative 81 and 1, or since the leading coefficient is 1, I just need two numbers that multiply to be negative 81 but add to be 0. So this factors to be x plus 9 and x minus 9. Hopefully you're seeing a little bit of a pattern here. If you look back at the first one, the 16x squared, if you were to take the square root of that, you would get 4x, which happens to be the first term in each of my binomial factors. The square root of 1 is 1, which happens to be the second term in each of my binomials. So notice 1 is plus, 1 is minus. Let's see if this all holds over here. The square root of 1x squared is x, that was the first term. The square root of 81 is 9, that's the second term. 1 is plus, 1 is minus. So your two binomial factors look exactly the same, except 1 is plus and 1 is minus. And this is called the dots method of factoring, which stands for difference of two squares. So we're going to try two more problems, but just use the pattern. So if we have x squared minus 4, well, it's difference, meaning subtraction. X squared is x times itself, and 4 is 2 times itself. It's 2 squared. So this would factor into x plus 2 and x minus 2. X squared minus 121. This is also difference from subtraction and then of two perfect squares. So this would factor to x being the first term in each binomial factor because that's the square root of x squared. And 11 would go in as the second term. One gets a plus, one gets a minus. And you could always check this via FOIL. Let's try two more. 49x squared minus 1, it is a difference, and 49x squared and 1 are both perfect squares. The square root of 49x squared would be 7x, so that's how we would start each binomial factor. Square root of 1 is 1, so 1 would be plus, 1 would be minus. Over here, 25x squared, the square root is 5x, so that should be the first term. The square root of 16 is 4, so that would be the second term. 1 gets a plus, 1 gets a minus. And you can see that as long as they're the exact same and 1 is a plus, 1 is a minus, when you're using FOIL to check this, the outside and inside terms would cancel each other out. So here you can see 5x times negative 4 is negative 20x, and 5x times 4 is positive 20x. So those middle terms would cancel out, and you'd only be left with 25x squared and the negative 16 when you're foiling to check. So this is just difference of two squares. Just practice it. Always look for the GCF first, but that's pretty much all you have to do.